Heidi ho, everyone. We're going to be looking at our next set of notes today. What color do we want? Which is polynomial operations. So again, when you are taking notes in your notebook, don't forget to write the date of the notes. Okay, and then also the title. So the title of today's notes is polynomial operations. Okay, so a couple things we're going to look at today is we're going to define three different things, and then we're going to look at what are some of the pieces in our polynomial, what are the different parts mean, what are the names of different parts, things like that. And then we're going to do three examples, I believe. Yep, three examples, and then we'll be done. So another short day of notes, which is exciting. And we're cruising. So we're just going to go ahead and start here with the definitions. Okay, so the first definition that we're going to look at is variable expressions. I apologize, the sun is totally blinding me right now. Kind of hard to see. So variable expression. So a variable expression is an expression. And then the question is always, what is an expression, right? Okay, great, but what is an expression? An expression is something without an equal sign, so no equal sign. So just as an example, I'll do this off to the side, like 2x plus 3 is an expression because there's no equal sign, right? Versus 2x plus 3 equals 7 is not an expression, right? This is not an expression because it has that equal sign in it. Okay, so it's an expression that has variables. So with variables. Okay, so like an example of this, an example of what something like this might look like. I have like 2x squared y plus 3z. Something like that. It's a variable expression because, right, there's no equal sign, so it's an expression, and it has variables. In this case, it has an x, y, and a z, but even if it just had one variable, it would still be a variable expression. The next term that we're going to define is term, which is funny. So this is a piece of an expression or equation so it's a piece of an expression or an equation, and it's going to be separated by, they're usually separated by a plus sign or a minus sign. Not always, but usually, okay? So what I mean by that is if I have, let's say I have a variable expression that's 4x plus 2. Okay, 4x is one term and 2 is one term. Okay, so there's two terms here in this expression. You can have an expression with one term or 6 terms, right? But in this case, there's two terms, 4x and 2, and they're being separated by this plus sign. And just as a reminder, what we call an expression with two terms, the word two should kind of give us a little helpful hint. This is called a binomial. So if I have an expression with two terms, it's called a binomial. If I have an expression with three terms, it would be a trinomial, and so on and so forth. Okay. Okie dokie. So we're gonna move on a little bit. Our next vocabulary word that we're gonna look at is like terms. So now that we know what terms are, we're gonna look at like terms. So these are terms with the same variable. Okay, so they both have x or they both have y or whatever. And I'm going to put the and in caps because this is really important, and the same exponent. Okay, so not only do they both have to have an x, let's say, for example, but if one of them was x squared, they would both have to be x squared. So like an example here would be like 2x plus 3 plus 4x, right? So this is an example. In this case, I have like terms, right? 2x and 4x. They both have the same exponent. And remember, if there's nothing written above the variable, then the exponent is a 1. So in this case, they both have an exponent of 1. So hopefully that kind of makes sense. So those two have the same exponent. Another example would be something like 4x squared plus x plus 5x squared plus 7 plus 3x. Whew, there's a lot of terms there. How many terms? There's 1, 2, 3, 4, 5 terms in this polynomial. And we're interested in which of those terms are like terms. So here I have an x, and that x is squared. So that is a like term with this 5x squared. So those are like terms. Okay. On that same note, here I have a 1x and a 3x. So those are like terms. Okay, so hopefully that kind of makes sense how we get those like terms there. So they have to have not only the same variable, but also the same exponent. Okay, so I'm going to go ahead and clear this, and we're going to talk about different parts of variable expressions. So different parts of variable expressions. Kind of went off the page, but that's okay. Okay, and so then what we're going to do, and of course I don't have black, so we have to go with the color, but that's okay, is kind of a little bit on the bigger side. We're going to write, actually, let's do it even further down. 4x squared y minus 2z minus x plus 4. And we're going to talk about some parts here. So the first thing I want to talk about is how many terms does this expression have? So I have one term here, right? Then a minus sign, so that stops the term, and then another term here where it's 2z. then a minus sign so it stops the term, and then another term at x, and then a plus sign, so then another term at 4. So here there are 4 terms. 4 terms. Okay? Then the next question is, how many of those terms are variable terms? How many of those terms have a variable in it? Well, this one does because of the x squared and the y. This one does because of the z. And this one does because of the x. So even though there's 4 terms total, there's only 3 variable terms. There's only 3 variable terms. And then that last term, that 4, because it's not a variable term, that's called the constant. It's called the constant. Okay, that all that means is that there is no variable. So that's what we call something with no variable. So in this case, this expression has 4 terms total. It has 3 variable terms and 1 constant. So again, we're going to look at now what are the different parts of a term. So I'm going to clear this. I'm going to do this again. Woohoo! Okay, so different parts of a term. So what are the different parts of a term? So I'm going to just write one of those terms from up above. So I'm going to write the 4x squared y. Okay, so that's just the term from up above in your notes. But I just want to go over some pieces of this guy. The number that's in front, so this guy right here, any number that's in front of variables is called the coefficient. Kind of a tricky term. And we're going to actually, what we're going to do is we're going to define it. Let's define coefficient, shall we? So in your notes underneath, we're going to write down what is a coefficient. And the definition of a coefficient is the number in front of a variable. So if there's a number in front of an x or in front of a y or whatever, that number is called a coefficient. Okay? And then the rest of this, let's go like a green. Okay? The rest of this, the x squared and the y, that's just called the variable part. So in this case, there's 2 parts of a term. There's the coefficient and there's the variable part. And the variable part is what all of the variables are, and then the coefficient is the number. So that's just a quick reminder on all of the, I'm really getting, let's see if we can turn more, there we go. Just a quick reminder on all of the different parts of the terms. Okay, and so what we're going to do now is we're going to do 3 examples of how do we combine like terms and how do we actually add these expressions together and subtract these expressions from each other and multiply these expressions. So we're going to do 3 examples. So here's our example 1. And we're going to look at how do we simplify And my problem is, parenthesis, negative 5x squared minus x plus 4. And I'm adding this to negative 3x squared minus 5x plus 2. Okay, so since I'm adding, I can kind of ignore these parentheses since I'm adding and there's no numbers like outside the parentheses doing anything. So all I'm going to do is I'm going to go through and I'm going to find my like terms. In this case, I have negative 5x squared and negative 3x squared. So if I add those two terms together, I get negative 8x squared. Okay, because I'm just adding. Then I'm going to go through and find more like terms. So here I have a negative x and a negative 5x. If I add those two terms together, negative x plus negative 5x is negative 6x. And then lastly, I have a 4 and a 2. So the question is, right, 4 plus 2 is 6. So plus 6. And that's it. I can't go any further than that. That's as far as I can simplify. That's it. That's all I can do. Let's look at another one. Next one is we want to simplify. So again, simplify. And I'm going to have a parenthesis, 8x squared minus 3x, close the parenthesis, minus, so now I'm subtracting, and I have 5x minus 5 minus 8x squared. Okay, so same idea. The only thing, and this is so important. If you are subtracting these two parentheses, you have to distribute the negative to every single term that follows it. Okay, I have to distribute the negative. And I'm even going to write it because it's so important. Distribute the negative. Don't forget. If you forget, you're going to get all messed up. Okay. So what that ends up doing is it does absolutely nothing for this first grouping. So that's going to stay 8x squared minus 3x. That is not changing. Okay. But what it does is this is almost like a negative 1, right? So negative 1 times 5x is negative 5x. Negative 1 times negative 5 is positive 5. And then negative 1 times negative 8x squared is positive 8x squared. And now I can go ahead and combine my like terms. So here I have an 8x squared plus an 8x squared. So that gives me 16x squared. I have a negative 3x and a negative 5x. So that gives me a negative 8x. And then this 5, there's nothing for that 5 to combine with, so it's just going to stay plus 5. And that's it. I can't simplify anymore because I have an x squared, an x, and a 5. Okay, so hopefully a nice little reminder. We have one more example to do. So I'm going to go ahead and erase, so if you need a pause, pause. Our last example, before the sun totally fries me, is multiplying. So how do I multiply, right? So I want to simplify. I have 2x plus 3 times x squared minus 4x plus 5. Probably should have given myself a little bit more room, but that's okay. So here, just what we have to remember, the most important part is distributing properly. So when I distribute, I am going to take my first term in the first parenthesis, and I'm going to multiply it by all 3 of the terms in the last parenthesis. In this case, there's 3, right? If there's 4, it would be all 4. But you multiply the first term in the first parenthesis by every single term in the other parenthesis. So let's do that first. 2x times x squared gives me 2x cubed, right? 2 times the 1 here gives me 2, and then x times x squared is x cubed. 2x times negative 4x is negative 8x squared. X times x is x squared. And then 2x times 5 is 10x. So that's step 1. Then step 2 is to take your second term and multiply it by every single term in the second parenthesis. Okay, so 3 times x squared is positive 3x squared. 3 times negative 4x is negative 12x. And 3 times positive 5 is positive 15. So now is my final thing is to just combine like terms. So I have a 2x cubed, but I have no other x cubes. So that is just going to stay 2x cubed. There's nothing else I can do with that. Then I have a negative 8x squared and then a positive 3x squared. So when I combine those, I get negative 5x squared. Then I have a positive 10x and a negative 12x. So when I combine those, I get negative 2x. And then lastly, I get plus 15 because that can't not combine with anything. And that's it. Okay, so those are the only examples I want to go over. The practice on this is already posted. So you can go ahead and do that. Make sure you do it on a separate sheet of paper. If you have any questions, reach out, let me know. Otherwise, bye-bye.